Buna, New Guinea. January 3rd, 1943, the morning air hangs heavy with moisture and the smell of rotting vegetation. Major Takeshi Yamamoto crouches in a spider hole 300 meters behind the forward defensive line, field glasses pressed against his face. Sweat runs down his temples despite the early hour. His uniform, once pressed and proper, now hangs loose on a frame that has lost 15 kilograms since arriving in New Guinea 4 months ago. Through the glasses, he watches American infantry approach a coconut log bunker 200 meters distant. The bunker is designated Position 7 in his defensive map. He knows everything about it. The bunker holds 8 of his men. Corporal Tanaka commands the position. 3 Type 92 heavy machine guns are positioned at precisely calculated angles, overlapping fields of fire exactly as doctrine prescribed, exactly as Yamamoto himself had supervised during construction. The logs are 40 centimeters thick at the minimum diameter. They were selected personally by Lieutenant Yoshida, the battalion's engineering officer, who had studied forestry at university before the war. Each log was cut from mature coconut palms, the wood dense and fibrous, layered 3 deep with sand-filled 55-gallon drums positioned between each layer. The drums had been scavenged from abandoned Allied supply dumps, repurposed into defensive materials. Each drum was filled carefully with local sand, then positioned to absorb blast fragmentation and provide additional mass. Artillery has struck Position 7 directly twice in the past week. Both times, 105mm American howitzer rounds. Both shells detonated on contact with the log surface. Both times, the bunker shook but remained intact. The defenders emerged shaken but alive. The logs had done their job. After each strike, Yamamoto had inspected the damage. Surface splintering, some displacement of the top layer, but the structural integrity remained sound. The bunker could withstand bombardment, or so he believed. The American infantry are moving cautiously. Yamamoto can see them through breaks in the kunai grass, perhaps 30 men. They advance in small groups, using available cover. Standard tactics, nothing unusual. They are still 150 meters from Position 7, well within range of Tanaka's machine guns. Yamamoto expects to hear the familiar sound of Type 92 fire at any moment. The sharp crack-crack-crack that would drive the Americans to ground, disrupt their advance, buy time for reserves to maneuver. Then he hears something different. Not the crack of rifles. Not the thump of mortars. A sound like tearing canvas amplified, sustained, mechanical, relentless. A sound he has never heard before but will never forget. Through his field glasses, Yamamoto sees the source. An American heavy machine gun, positioned behind a slight rise in the terrain. The weapon is massive compared to Japanese machine guns. Even at this distance, he can see the thick barrel, the belt feed mechanism, the tripod mount that seems overbuilt for infantry equipment. 2 men service the weapon. The gunner behind the sights, an assistant feeding ammunition. The sound continues. It is not the intermittent bursts of a light machine gun. It is continuous roaring. The weapon fires so rapidly that individual shots blur into a sustained noise that vibrates through the humid air. Yamamoto watches the tracers. Every 5th round glows red as it arcs toward Position 7. The trajectory is flat, direct. The rounds strike the bunker wall in a tight pattern. The sound lasts 11 seconds by Yamamoto's watch. 11 seconds of continuous fire. Perhaps 80 rounds. Maybe 100. The volume is difficult to judge through the ambient noise of combat. When the firing stops, the sudden silence is profound. Yamamoto keeps his binoculars trained on Position 7. He waits for return fire. For muzzle, flashes from Tanaka's Type 92s. For some indication that his men are responding to the threat. Nothing. The bunker is silent. No movement, no defensive fire. The position that should be pouring rounds into the American advance sits inert. He lowers his binoculars slowly. His hands are shaking. Not from fear exactly. From the sudden understanding of what he has just witnessed, that bunker was supposed to hold for days. It was positioned at a critical choke point in the defensive line. The timber was dense enough to stop 30 caliber rounds. Multiple layers provided redundancy. The sand drums absorbed blast fragmentation. Japanese engineers had spent a week positioning it for maximum defensive advantage. The firing ports provided excellent fields of fire while minimizing exposure. 11 seconds, 8 men, 3 machine guns. Gone. Yamamoto forces himself to breathe steadily. He has been an officer since 1937. China first, then the Philippines, now New Guinea. 6 years of combat experience. He has seen men die in every conceivable way: artillery, air attack, close combat, disease. But this is different. This is systematic destruction of a prepared position by small arms fire. That should not be possible. Bunkers exist specifically to protect defenders from small arms. That is their purpose. Their entire reason for existence. American infantry are advancing now. They move quickly through the field of fire that Position 7 should be contesting. No one shoots at them. They reach the bunker's perimeter. Yamamoto sees them move around the structure, checking angles. One soldier pulls a grenade, lets the spoon fly, tosses it through a firing port. The muffled explosion is almost an afterthought. The Americans don't even go inside immediately. They simply move past the bunker toward the next defensive line. They know the position is neutralized. 11 seconds of fire was sufficient. No need for extended combat, no need for flamethrowers or demolition charges. The heavy machine gun did the job completely. The weapon was an M2 Browning heavy machine gun. The Americans called it Mar-Deuce, a nickname that suggested familiarity, affection even, for a weapon that Japanese forces were learning to fear. The specifications told part of the story. Caliber .50 inches, 12.7 millimeters, substantially larger than the 7.7 millimeter rounds used by Japanese machine guns. The difference might seem small when written on paper, 12.7 versus 7.7. But that difference translated into dramatically different performance characteristics. Belt fed from disintegrating metallic links, water-cooled when mounted on ground tripods, though the barrel was heavy enough to function air-cooled for sustained periods. The aircraft variant was specifically air-cooled, relying on airflow for cooling. Cyclic rate 450 to 550 rounds per minute for the M2 HB and heavy barrel version used by infantry. Faster rates, up to 800 rounds per minute for the aircraft AN-M2 variant. Muzzle velocity 2,910 feet per second, nearly 900 meters per second. That velocity, combined with the bullet mass, created kinetic energy levels that overwhelmed defensive structures. Effective range 1,800 meters. That meant the weapon could engage targets at distances where return fire from standard infantry weapons was largely ineffective. An M2 crew could position themselves beyond the effective range of Japanese machine guns and still suppress positions with devastating accuracy. Weight was substantial, 38 kilograms for the gun itself, another 20 kilograms for the tripod. Total combat weight of 58 kilograms without ammunition. The ammunition added significant additional weight. Each loaded belt of 100 rounds weighed approximately 15 kilograms. A complete M2 setup with gun, tripod, and 500 rounds of ammunition required multiple men to transport. This was not a weapon designed for rapid repositioning. It was designed for sustained defensive or suppressive fire from prepared positions. But numbers told only part of the story. The part that mattered, the part that Yamamoto had just witnessed, was what those numbers meant when translated into impact. When a .50 caliber round, traveling at 2,900 feet per second, struck a target, the kinetic energy transfer was catastrophic. The armor-piercing rounds, specifically designed for defeating hardened targets, could penetrate 22 millimeters of hardened steel plate at 100 meters, 19 millimeters at 500 meters. Against coconut logs, against sand-filled drums, Against the reinforced positions that Japanese engineers thought were impregnable, the M2 performed simple physics. Mass times velocity equals penetration, and the M2 had both in quantities that overwhelmed defensive calculations. The ammunition itself was a family of specialized rounds: ball ammunition for general-purpose use, armor-piercing for hardened targets, armor-piercing incendiary for vehicles and fuel storage, tracer rounds for target designation and fire adjustment. Each type had specific applications. Together, they provided crews with flexibility to engage any target type effectively. The armor-piercing round was the bunker killer. The projectile featured a tungsten chromium steel core, surrounded by a brass jacket with a lead filler at the nose. The design was sophisticated. The soft lead and brass acted as a cap, similar to armor-piercing artillery shells. Upon impact, the softer metals deformed, improving the penetration characteristics of the hard tungsten core. The core maintained its structural integrity through the impact, driving through materials that would have stopped conventional rounds. Against a coconut log bunker, the physics were unforgiving. A single armor-piercing round might penetrate 20 to 30 centimeters of coconut palm wood, depending on the angle of impact and the wood's density. That alone was concerning. But the real devastation came from the sustained fire that the M2 could maintain. One round penetrating 20 centimeters is manageable. 100 rounds, concentrated on a 2-meter section of wall, becomes systematic destruction. The ammunition feed system allowed for continuous fire limited only by barrel heating and ammunition supply. The disintegrating link belt meant no stoppage for reloading magazines. An assistant gunner could keep feeding belts as long as ammunition was available. In practice, American units allocated substantial ammunition reserves for their M2S. 2,000 rounds per gun per day during active operations was standard. That's enough ammunition to suppress 20 bunkers using the 75 to 100 round per target calculation that had become standard practice. Yamamoto had been a line officer since 1937, China first, where Japanese forces enjoyed material superiority over Chinese defenders. The Philippines, where American and Filipino forces were inadequately equipped for sustained resistance. Now New Guinea, where the material balance was shifting dramatically. He understood defensive warfare from both sides. Japanese infantry doctrine emphasized strong-point defense, mutually supporting positions, interlocking fields of fire. The principle was sound. Concentrate defensive firepower to create kill zones that attacking forces cannot penetrate without unacceptable casualties. The bunkers at Buna had been constructed according to specifications refined over months of combat experience. They incorporated lessons learned from the Kokoda Trail campaign, from earlier engagements with Australian forces, from after-action reports filed by survivors of failed positions. They worked against 30-caliber machine guns, the M1919 Browning that American infantry used. The logs were thick enough to stop those rounds. The layered construction provided redundancy. Even if the outer layer was damaged, inner layers remained intact. They worked against grenades. The bunker roofs were thick enough to withstand fragmentation. Entrances were designed with multiple angles to prevent grenades from being thrown directly inside. Defenders could retreat into protected sections when grenades were used. They even worked against mortars and light artillery when properly constructed. The layered log and sand construction absorbed blast effects. Direct hits caused damage but rarely complete structural failure. Repairs could be made between bombardments. Positions remained viable. They did not work against the M2 Browning. That was the conclusion forcing itself into Yamamoto's mind as he watched American infantry continue their advance. The defensive doctrine he had learned, that he had taught to his subordinates, that he had implemented across dozens of defensive positions, was being invalidated by a single weapon system. Not because the doctrine was flawed in principle, but because it was designed to resist threats that the M2 simply overwhelmed through brute kinetic force. February 19, 1943. Yokosuka Naval Arsenal. A captured M2 Browning sits on an examination table. 3 officers from the Imperial Japanese Army Ordnance Department stand around it. The weapon had been recovered from a downed American bomber near Rabaul. The crew had destroyed most of their equipment before capture, but the M2 remained functional, an intact specimen. The first one Japanese engineers had been able to examine in detail. Chief Engineer Matsuda Kenji runs his hand along the barrel, 114 centimeters long. The barrel alone weighs 13 kilograms. The complete weapon with tripod weighs 58 kilograms, nearly twice the weight of a Type 92 heavy machine gun. The American weapon seems excessive, overbuilt, impractical for mobile infantry operations. But Matsuda has read the field reports. He knows what this weapon can do. His examination would need to answer 2 questions. First, why does it work so effectively against fortified positions? Second, can Japan produce something equivalent? The answers would reshape Japanese defensive doctrine for the remainder of the war. The disassembly proceeds methodically. The receiver, the bolt, the barrel assembly, the recoil mechanism. Each component is measured, weighed, photographed. Tolerances are recorded. Materials are analyzed. The examination takes 6 days. Matsuda fills 3 notebooks with observations and calculations. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The barrel tells the first story. American ordnance specifications called for chrome molybdenum steel. The rifling is cut to precise depth, 8 grooves, right-hand twist, 1 turn in 15 inches. The chamber is dimensioned to tolerances measured in hundredths of a millimeter. The barrel can withstand chamber pressures of 54,000 pounds per square inch repeatedly without deformation. Japanese Type 92 barrels were made from adequate steel, but not exceptional steel. The metallurgy was good enough for the Type 92's lower pressure 7.7 mm rounds. But adapting that same manufacturing process to build something capable of handling 50 BMG pressures would require better alloys. Japan's steel production in 1943 totaled just over 6 million tons. American production exceeded 80 million tons. The specialized steel needed for M2 barrels competed with steel allocations for warships, aircraft, and artillery. The ammunition is more revealing than the weapon itself. Matsuda examines captured .5 OBMG rounds. The armor-piercing variant features a tungsten chrome steel core. The hardest penetrator material Japan could produce used tungsten carbide, but supplies were already insufficient for machine tool production. Using tungsten for ammunition would mean choosing between bullets that could defeat bunkers and lathes that could manufacture precision parts. The ballistics are sobering. The .5 OBMG round exits the muzzle at 2,910 feet per second, carrying over 13,000 foot-pounds of energy. At 200 meters, it still carries 9,000 foot-pounds. A Type 92 round at muzzle carries 3,000 foot-pounds. Even accounting for the M2's greater weight, the power differential is absolute. The American weapon delivers 3 times the kinetic energy at comparable ranges. Against a coconut log bunker, physics is unforgiving. The logs that Japanese engineers used were chosen specifically for their properties. Coconut palm wood is fibrous, dense. It doesn't shatter when struck. It absorbs. Impact. A .30 caliber round penetrates perhaps 10 centimeters. Fired at an angle, it may deflect entirely. The rounds that do penetrate lose most of their energy in the wood itself. By the time they reach the interior, their lethality is reduced. A .5 OBMG armor-piercing round treats coconut logs differently. The tungsten core maintains structural integrity through the initial impact. The round's velocity ensures it carries sufficient energy through the first layer, the second layer, sometimes the third. Testing at Yokosuka demonstrates that a .5 OBMG round can penetrate 45 centimeters of coconut log when striking perpendicular. That's more than the thickness of most bunker walls. But penetration alone doesn't explain the weapon's effectiveness. The real devastation comes from sustained fire. The M2's cyclic rate means a trained crew can place 450 rounds on target per minute, 7.5 rounds per second, against a bunker with a 2 meter by 1 meter facing that creates a density of fire that systematically defeats any fixed position. The first rounds probe for weaknesses, firing ports, ventilation gaps, joints between logs. The next rounds exploit those openings, and the rounds after that reach inside. A bunker that might withstand 10 or 20 hits cannot withstand 100. The cumulative damage becomes catastrophic. Logs split, joints separate. The structural integrity fails not from a single overwhelming blow but from sustained mechanical destruction. March 1943. Field testing at Yokosuka. The captured M2 is mounted on a tripod. A mock bunker has been constructed using coconut logs shipped from New Guinea. The specifications match those used in actual defensive positions. 3 layers of logs, each log 40 centimeters diameter. 55-gallon drums filled with sand positioned between log layers. Total wall thickness 120 centimeters. The test begins at 200 meters. Standard engagement range for bunker suppression. The ammunition is captured .50 BMG armor-piercing rounds. 75 rounds are allocated for the test. That's what American units typically expended to neutralize a single bunker based on after-action reports. The first round strikes the center of the forward wall. The impact sound is distinctly different from .30 caliber strikes. Sharper, more penetrating. A visible divot appears where the round struck. The second round strikes 6 centimeters to the right. The third round strikes between the first 2 impacts. The firing pattern is methodical, precise, hammering the same small area repeatedly. After 25 rounds, the first log begins to show structural failure. Cracks radiate from the impact zone. After 40 rounds, a section of the first log separates completely. The second layer is now exposed. After 55 rounds, the second layer shows similar damage. After 70 rounds, daylight is visible through the bunker wall. The final 5 rounds enter the bunker interior. The test supervisors examine the results. The damage pattern is exactly what field reports described. Systematic structural defeat through concentrated fire. The bunker didn't collapse. The roof remained intact, but the wall had been compromised to the point where defenders inside would be exposed to direct fire. Anyone attempting to man the firing ports would be in the direct path of incoming rounds, Matsuda writes in his report. The American M2 heavy machine gun achieves bunker suppression not through explosive force, but through sustained kinetic bombardment. The weapon functions as a rapid-fire anti-material rifle. Our defensive positions are designed to withstand brief, intense bombardment, followed by infantry assault. The M2 allows American forces to maintain suppressive fire indefinitely while maneuvering to flanking positions. The tactical implications are immediate. If American forces can systematically reduce bunkers with small arms fire, then Japanese defensive doctrine requires fundamental revision. The bunkers that worked at Buna were failing not because they were poorly constructed, but because they were designed to resist the wrong threat. April 1943. A conference room in Tokyo. Matsuda presents his findings to senior officers from the Army and Navy. The technical analysis is supplemented by after-action reports from New Guinea. The pattern is consistent across multiple engagements. American forces identify Japanese bunkers through reconnaissance. They position M2 heavy machine guns at distances between 150 and 300 meters. They pour sustained fire into the positions until return fire ceases. Then infantry advances with flamethrowers and explosives to clear the bunker completely. The officers ask the obvious questions. Can Japan produce an equivalent weapon? Can Japanese defensive positions be modified to resist M2 fire? Matsuda's answers are not what they want to hear. Japan can theoretically produce a weapon similar to the M2. The technical knowledge exists. Japanese engineers understand the operating principles. Gas-operated, belt-fed, heavy barrel. The mechanical design could be replicated, but replication requires industrial capacity that Japan lacks. The M2's barrel requires specialized steel produced in controlled atmosphere furnaces. Japan has such furnaces, but their output is already fully allocated. The precision machining demands hardened tool steel that's in desperately short supply. The ammunition requires tungsten for armor-piercing cores. Japan's tungsten reserves are insufficient for existing programs. Even if these material constraints could be overcome, there's the production challenge. Colt, Frigidaire, AC Spark Plug, and other American manufacturers were producing thousands of M2S per month by early 1943. Japan's entire heavy machine gun production for 1942 totaled fewer than 3,000 units of all types. Matching American M2 production would require converting factories, currently building aircraft engines and tank components. The timeline is impossible. If Japan started immediately, first prototypes might be ready by late 1944, mass production by mid-1945 at the earliest. And that assumes no disruption from bombing, no material shortages, no competing priorities for the same resources. The more answerable question is defensive adaptation. If bunkers cannot resist M2 fire, what modifications might improve survivability? Matsuda proposes several options. Increased wall thickness, 5 layers of logs instead of 3. But thicker walls mean more construction time and more materials. Positions that took 1 week to build would require 3 weeks. Scarce timber would be exhausted faster. Alternative materials: reinforced concrete, steel plating. But concrete requires cement that's allocated to airfield construction and coastal fortifications. Steel plating is needed for warships and tanks. Diverting either to bunker construction means accepting shortages elsewhere. Positional adjustments: building bunkers deeper, positioning them to minimize exposure, creating dummy positions to draw fire. These tactical modifications require no additional materials. They can be implemented immediately. They become the foundation of revised defensive doctrine. But the fundamental problem remains unsolvable. The M2 Browning represents American industrial capacity operating at scales Japan cannot match. One M2 costs approximately $600 to manufacture. American production budgets allowed for essentially unlimited quantities. Japan's entire military budget for 1943 was stretched across all weapons systems, all theaters, all services. The strategic calculation is brutal. American forces advancing through the Pacific Islands would have M2 support for every engagement. Japanese forces defending those islands would face those M2S with bunkers that offered decreasing protection. The mathematics of attrition favored the force that could maintain indefinite material superiority. May 1943, Matsuda returns to Yokosuka to continue his analysis. The captured M2 has been test-fired over 1,500 rounds. It shows minimal wear. The barrel remains within tolerance. The action cycles smoothly. American ordnance manuals specify that M2 barrels should be replaced after 40,000 rounds in ground combat, after 10,000 rounds in aircraft use due to higher cyclic rates. 40,000 rounds. That's enough ammunition to suppress 80 bunkers using the 75-round standard allocation. A single M2, properly maintained, could theoretically support an infantry battalion through an entire campaign. The weapon's longevity is as significant as its firepower. Japanese heavy machine guns required barrel replacement more frequently. The Type 92 specification called for barrel change after 5,000 rounds. Not because the barrel wore out, but because heat buildup caused accuracy degradation. The difference comes down to manufacturing precision and material quality. American barrels were better made from better steel. That simple fact multiplied their effectiveness across thousands of combat engagements. June 1943. Reports from the Solomon Islands describe American forces using M2S mounted on patrol boats. The weapons provide suppressive fire against coastal positions during amphibious landings. Their range allows boats to engage targets from distances where return fire is ineffective. Japanese coastal defenders report feeling helpless as M2 rounds systematically destroy their fighting positions before infantry even reaches the shore. The tactical flexibility of the M2 surprises Japanese analysts. The same weapon serves as aircraft armament, vehicle armament, anti-aircraft, defense, and direct infantry support. American forces don't need specialized weapons for each role. The M2 handles all of them with minimal modification. That versatility simplifies logistics, training, and maintenance. Japan's weapons philosophy emphasized specialized designs, different guns for different purposes. The result was a logistics nightmare. Spare parts weren't interchangeable between systems. Ammunition supplies had to account for multiple calibers. Training required familiarization with multiple weapons platforms. The American approach of using one weapon across multiple roles eliminated these complications. July 1943. New defensive guidelines are distributed to units in the Pacific. Bunker construction standards are revised. 5-layer log walls become mandatory where materials permit. Firing ports are reduced in size. Dummy positions are emphasized. Bunkers are to be positioned in depth, not along the beach, to complicate American targeting. The guidelines acknowledge what cannot be changed. American material superiority will continue. Japanese positions will face M2 fire in every engagement. Defenders must accept that bunkers provide concealment more than protection. The goal is not to stop American attacks, but to delay them long enough for counterattacks to develop. Private conversations among officers are more candid than official documents. The M2 represents a category of American advantage that Japan cannot overcome through tactical innovation or fighting spirit. Industrial capacity determines what weapons reach the battlefield. American factories produce M2S faster than Japanese factories can produce comparable weapons. That disparity extends to ammunition, spare parts, replacement barrels, everything needed to sustain combat operations. August 1943. Matsuda completes his final report on the M2 Browning. The document runs to 73 pages, including technical diagrams, metallurgical analysis, and strategic recommendations. It is marked Top Secret. Distribution is limited to senior officers at Army and Navy headquarters. The report will be read carefully. Its conclusions will be discussed in quiet meetings. But it will not change strategic reality. That reality is determined by industrial capacity, not by engineering knowledge. Japan entered the war with inferior industrial capacity compared to the United States. That was acknowledged even before Pearl Harbor by those willing to look at the numbers honestly. Admiral Yamamoto himself had warned that Japan could maintain offensive operations for 6 months, perhaps a year. After that, American production would begin to overwhelm Japanese forces through sheer material superiority. 18 months into the war, that prediction is proving accurate. American production increases month by month. Steel output rises. Aluminum production expands. Manufacturing capacity grows as new factories open and existing facilities expand. Japanese production, by contrast, stagnates or declines. Raw material shortages constrain output. Bombing disruption interrupts supply chains. Skilled workers are drafted to replace combat losses. The M2 Browning is not Japan's most serious problem when viewed in isolation. American aircraft carriers pose a greater threat to naval operations. Submarines are strangling supply lines. 4-engine bombers are extending American air power across vast distances. The list of critical threats is long and growing. But the M2 represents something psychologically devastating in a way that capital ships and bombers do not. It's a small arms weapon. Infantry equipment. The kind of weapon where tactical skill and training should matter more than industrial output. This is not a B-17 requiring thousands of skilled workers and sophisticated manufacturing facilities. This is not an Essex-class carrier demanding years of construction and massive resource allocation. The M2 is a machine gun. Japanese forces have machine guns too. Excellent ones, in fact. The Type 92 is reliable, accurate, well-designed. Japanese infantry are skilled at employing their weapons effectively. Tactical doctrine is sound. Training is rigorous. Yet none of that matters when American forces systematically suppress Japanese positions using weapons that Japanese industry cannot produce in comparable quantities. If industrial capacity determines outcomes even at the level of individual infantry weapons, then what hope exists for competing in aircraft, ships, or tanks where the resource requirements are orders of magnitude larger? That's the question Matsuda does not write explicitly in his report, but it underlies every technical recommendation he makes. The subtext is clear to anyone reading carefully. Japan cannot win a material contest against American industrial output. September 1943. Field reports from New Georgia in the Solomon Islands provide additional confirmation of M2 effectiveness. American Marine Corps units advancing through jungle terrain encounter Japanese defensive positions similar to those at Buna. Coconut log bunkers, interlocking fields of fire, prepared positions with good sight lines. The Marines deploy M2s forward with the assault units, not in rear positions providing indirect support, but moving with the infantry, establishing firing positions at ranges of 100 to 300 meters from identified Japanese bunkers. The engagement pattern is becoming standardized. Reconnaissance identifies the position. M2 crews maneuver to advantageous firing positions. Sustained fire suppresses the bunker. Infantry advances during the suppression. Bunker is cleared with grenades and flamethrowers. Japanese soldiers who survived M2 encounters describe a particular helplessness. Sergeant Hiroshi Nakamura, evacuated from New Georgia after being wounded, provides a detailed account during his medical recovery in Rabaul. His testimony is recorded by intelligence officers seeking to understand American tactics. We heard the weapon before we saw it. The sound is distinctive, not like their .30 caliber machine guns, heavier, sustained. The rounds struck our bunker wall like hammers. Continuously, we could not return fire. Anyone who approached a firing port was exposed to the incoming rounds. The logs began to splinter after perhaps 1 minute. Fragments filled the interior. We pressed ourselves against the rear wall, away from the impacts, but the firing continued. 2 minutes. 3 minutes. The wall was coming apart. Light appeared through gaps in the logs. Then the rounds were inside, ricocheting. My squad leader was killed. 2 others wounded. We could not stay. We evacuated through the rear entrance and withdrew. The account is corroborated by similar testimonies from other survivors. The pattern is consistent. M2 fire forces defenders to choose between exposing themselves to return fire or abandoning their positions. Either choice results in position loss. The bunkers cannot fulfill their defensive function when subjected to sustained .50 caliber fire. October 1943. Staff officers at Imperial General Headquarters review the accumulated evidence from 6 months of fighting across the Pacific. The tactical situation is deteriorating. American forces advance steadily. Japanese defensive positions fall faster than anticipated. Casualties are higher than projections. Supply lines are being interdicted by submarines. Reinforcements cannot reach forward positions in adequate numbers. The M2 is one factor among many contributing to this deterioration, but it exemplifies a larger problem. American forces arrive at each battle with more of everything: more artillery, more aircraft, more naval support, more ammunition, more medical supplies, more replacement equipment. The material abundance allows tactical flexibility that Japanese forces cannot match. A Japanese battalion defending an island must conserve ammunition carefully, rationing fire to ensure supplies last through the engagement. American battalions fire without such constraints. If more ammunition is needed, more arrives. Logistics support is essentially unlimited from a Japanese perspective. The difference manifests in how battles develop. Japanese defenders must husband resources, making each position count because replacements are uncertain. American attackers can afford to expend material freely because resupply is assured. It's not a difference in courage or tactical skill. It's a difference in industrial support that determines combat outcomes before the first shot is fired. November 1943. The Battle of Tarawa in the Gilbert Islands provides another demonstration of M2 employment in Pacific Island warfare. The Japanese garrison on Betio Island has constructed substantial defences. Concrete bunkers reinforced with steel, coconut log positions covering the beach approaches, anti-tank, ditches, barbed wire, minefields. This is not the hastily prepared field fortifications of Buna. This is systematic defensive engineering executed over 18 months of preparation. American Marine forces faced devastating casualties during the initial landings. The concrete bunkers prove resistant to naval bombardment. Japanese defenders inflict heavy losses on Marines crossing the exposed beaches. For several hours, the landing appears to be failing. Marines are pinned down on narrow beachheads, unable to advance inland. But Marine units establish M2 positions on the seized portions of the beach. The heavy machine guns provide suppressive fire that prevents Japanese defenders from maintaining continuous fire on the exposed Marines. The M2S cannot penetrate the concrete bunkers that require direct artillery or demolition charges, but they can suppress the coconut log positions. They can engage firing ports. They can force defenders to remain in cover while engineers advance with explosives. The battle is extraordinarily costly for American forces. More than 1,000 Marines killed, over 2,000 wounded. But the island falls in 76 hours. The Japanese garrison of nearly 5,000 is virtually annihilated. Only 17 prisoners are taken. Everyone else dies defending their positions. American after-action reports note the M2's contribution to the eventual success. The weapon provided critical suppressive fire during the consolidation phase. It allowed Marines to maneuver against positions that would otherwise have inflicted even higher casualties. The reports recommend increasing M2 allocation for future amphibious operations. More weapons, more ammunition, more crews trained in bunker suppression techniques. December 1943. As the war enters its third year, the cumulative effect of material advantage becomes increasingly apparent. American forces don't just have more M2S now. They have more of everything, and the gap widens monthly. Japanese intelligence estimates American M2 production at 6,000 to 7,000 units per month. Cumulative production since Pearl Harbor approaches 130,000 weapons. Even accounting for combat losses, training requirements, and distribution across multiple theaters, American forces have essentially unlimited M2 availability. Every infantry battalion has organic M2 support. Every vehicle can mount one if needed. Every defensive position can be equipped with multiple weapons. The surplus capacity means weapons can be allocated generously without concern for shortages. Japanese production of comparable weapons remains below 500 units monthly. That's all types of heavy machine guns combined. Type 92 production, Type 97 aircraft guns, Type 93 13mm weapons. Everything added together barely exceeds 500 units per month. Distribution priorities favor homeland defense and China operations. Units in the Pacific receive minimal replacement equipment. Weapons lost in combat often cannot be replaced for 3 to 6 months. Units operate with degraded equipment strength. Machine gun sections that should have 3 weapons operate with 1 or 2. Ammunition allocations decrease as supply chains are interdicted. The material degradation is systematic and accelerating. The numerical gap widens continuously. Each month, American M2 inventory increases by thousands. Japanese inventory increases by hundreds, or remains static as losses exceed production. The mathematics project an increasingly unfavorable situation for Japanese forces across all equipment categories. Japanese soldiers who survived M2 encounters describe a particular helplessness. Artillery you can take cover from. Air attacks you can disperse against. But the M2 pins you in your position and systematically destroys that position around you. 75 rounds over 15 seconds. That's all it takes. Then American infantry advances to finish what the M2 started. September 1943. The Battle of Leh in New Guinea demonstrates revised Japanese defensive tactics. Bunkers are positioned in depth. Dummy positions draw initial fire. Actual defensive positions are better concealed. The modifications slow American advances. They don't stop them. M2s still suppress positions. Infantry still advances. The territory still changes hands. After action assessments note that Japanese casualties are somewhat lower when improved defensive techniques are employed. Somewhat lower means 200 men lost instead of 300. It's an improvement measured in suffering rather than strategic outcome. October 1943. Production reports from American manufacturers show M2 output exceeding 6,000 units per month. That's more heavy machine guns than Japan produces in an entire year of all types combined. The numerical advantage compounds every month. American units replacement weapons within weeks. Japanese units make do with damaged equipment because replacements are months away if they come at all. The reliability difference matters more as campaigns extend. An M2 that fired 1,500 rounds in testing at Yokosuka might fire 30,000 rounds in combat and remain serviceable. Japanese weapons showed higher failure rates. Parts wore out faster. Repairs required specialized knowledge. The cumulative effect of reliability differences is that American weapons maintain effectiveness, while Japanese weapons degrade. November 1943. Tarawa demonstrates M2 effectiveness in a new context. Marine Corps forces use M2s mounted on amphibious vehicles during the landing. The weapons provide fire support before infantry reaches the shore. Japanese defenders in concrete bunkers report that M2 fire, while not penetrating reinforced concrete, keeps them suppressed during the critical minutes when Marines establish beachheads. The psychological impact of sustained heavy machine gun fire cannot be measured precisely, but after-action reports note its effect. Defenders who might have attempted to reposition or call artillery fire instead remain in cover. The weight of incoming fire creates a calculation. Expose yourself to return fire and risk being struck by .50 caliber rounds, or remain in cover and allow American infantry to advance. December 1943. Reports from the Central Pacific describe American forces using multiple M2s in coordinated fire. 4 guns firing in sequence maintain continuous suppression. As one gun changes barrels or reloads, another continues firing. The technique ensures no gap in coverage. Japanese positions face uninterrupted fire for minutes at a time. The ammunition expenditure is staggering from a Japanese perspective. American forces allocate 2,000 rounds per M2 per day during active combat. That's more ammunition than a Japanese heavy machine gun company might have for an entire week. The difference reflects fundamentally different logistics philosophies. American supply chains assume abundant consumption. Japanese supply chains enforce conservation. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. January 1944. A year after Yamamoto watched that bunker fall in 11 seconds, revised casualty statistics show the ongoing cost. Japanese positions in the Pacific Islands average 3 days before being overrun when facing American attacks supported by M2s. Positions without M2 opposition might hold for a week or more. The difference is measurable. Systematic. The causation is complex. M2 fire is one factor among many. Artillery, air support, tactical coordination, numerical superiority all contribute to American success. But the M2 represents a baseline capability that multiplies the effectiveness of everything else. It allows infantry to suppress positions without calling for artillery support. It provides sustained fire during advances. It creates the conditions where other weapons can be employed effectively. February 1944. Matsuda's classified report on the M2 Browning circulates among staff officers. The technical conclusions are noted, the strategic implications are understood. But understanding changes nothing. Japan cannot produce M2 equivalents in meaningful quantities. Defensive positions cannot be made impervious to M2 fire without materials that don't exist. The tactical advantages American forces enjoy will persist for the duration of the war. The only question is how to minimize losses while conducting a fighting retreat. Improved defensive techniques help. Better positioning reduces casualties. But the fundamental imbalance remains. American industrial output continues growing. Japanese capacity continues shrinking. The gap widens monthly. 44. Training exercises at Yokosuka demonstrate Japanese countermeasures against M2 fire. Trainees practice rapid movement between positions. They learn to identify M2 positions by sound and muzzle flash. They practice suppressive fire techniques designed to force American crews to take cover. The training is realistic about its limitations. These techniques might improve survival odds. They will not change battle outcomes. Senior officers understand the mathematics. Japan is fighting a war of industrial attrition against an opponent with 10 times the production capacity. Every category of equipment shows similar disparities: aircraft, warships, vehicles, ammunition. The M2 Browning is simply one visible example of a comprehensive material disadvantage. Some officers advocate for fundamental strategic changes. Negotiate a settlement before losses become unsustainable. Redirect resources from offense to homeland defense. These proposals are noted and filed. National policy remains committed to continued resistance. The retreat continues, island by island, each defensive position slightly more expensive for American forces to overcome, but none capable of holding indefinitely. April 1944. Combat reports from the Marshall Islands describe a new pattern. American forces don't always assault bunkers directly anymore. Instead, they bypass them. M2 fire suppresses the position while infantry advances past it. The bunker's garrison finds itself surrounded, cut off from supplies and reinforcements. Some positions hold for days in isolation before ammunition runs out. The tactical innovation demonstrates American confidence. They can afford to bypass strongpoints because they have the firepower to keep them suppressed indefinitely. Japanese forces cannot afford similar tactics. Bypassing American positions means those positions interdict supply lines and call artillery fire on advancing forces. The mobility allowed by material superiority creates options that doctrine alone cannot provide. May 1944. Matsuda receives orders to begin analysis of American ammunition production capacity. The question is not whether Japan can match it, but rather how long Japanese reserves will last given current consumption rates. The analysis reveals sobering projections. At current loss rates, ammunition stocks will become critically low by mid-1945, even without increased combat intensity. The Americans face no such constraints. Their ammunition production exceeds consumption. Stockpiles grow. Units receive allocations based on mission requirements rather than supply availability. The freedom to use ammunition as needed rather than hoarding it for critical moments changes how American forces fight. Suppressive fire becomes standard practice rather than a luxury reserved for major assaults. June 1944. The Battle of Saipan demonstrates everything Japanese defenders have learned about facing M2 supported attacks. Positions are in depth. Construction incorporates all the improvements developed over 18 months of analysis. Defenders employ all the trained countermeasures. American forces still take the island. The pace is slower. American casualties are higher. But the outcome remains predetermined by material factors. After-action reports note that Japanese defensive positions held 30% longer than positions at Tarawa 6 months earlier. The percentage improvement represents knowledge applied successfully, but 30% longer still means positions fall within days rather than weeks. The strategic calculus has not changed. American forces accept the casualties because they can replace losses faster than Japan can. July 1944. Production figures show American M2 output now exceeds 7,000 units monthly. Cumulative production since Pearl Harbor approaches 150,000 weapons. Even accounting for combat losses, American forces have overwhelming material superiority in heavy machine guns. Every infantry battalion has organic M2 support. Every vehicle can mount one. Every position can be suppressed. Japanese production of comparable weapons remains below 400 units monthly. Distribution priorities favor homeland defense. Units in the Pacific receive minimal replacement equipment. Weapons lost in combat often cannot be replaced for months. The numerical gap widens continuously. August 1944. 3 years into the war, the strategic situation is clear to Japanese staff officers, even if public declarations remain optimistic. American industrial capacity continues growing. Every category of production shows increasing output. Japan's industrial base is contracting under bombing pressure and material shortages. The war cannot be won through tactical excellence or fighting spirit. Material factors are decisive. The M2 Browning represents this reality in miniature. It's a well-designed weapon, produced in unlimited quantities with abundant ammunition supplied reliably. Japanese forces face it in every engagement. They have developed countermeasures that provide marginal improvements. They cannot match its firepower or its availability. The lesson applies across all categories of equipment. September 1944. Matsuda receives orders to shift his focus from analyzing American equipment to maximizing Japanese production from available materials. The mandate acknowledges implicitly what cannot be stated officially. Japan will not match American output. The goal is to provide enough equipment to make continued resistance costly for American forces, while preserving industrial capacity for eventual homeland defense. The analysis of the M2 Browning concludes with a simple observation noted in Matsuda's private journal. The Americans built a weapon designed for sustained use across years of service. We built weapons designed for brief, intense campaigns followed by victory. Their assumptions matched the war they needed to fight. Our assumptions did not. The comment appears on page 347 of his notes. It's crossed out. Later entries focus on technical matters, manufacturing processes, material substitutions, efficiency improvements, the kind of practical engineering that doesn't question strategic direction but works within imposed constraints. October 1944. The Battle of Leyte Gulf marks the effective end of Japanese naval power in the Pacific. American forces land in the Philippines with M2 support at every level. Beach defenses, inland positions, mountain strongholds all face the same systematic suppression. Japanese defenders fight with increasing desperation and decreasing effectiveness. Combat reports describe bunkers that held for 3 days, then 2 days, then hours. The decline reflects multiple factors: reduced construction time as American advances accelerate, fewer trained defenders, ammunition shortages. But consistently the reports mention M2 fire as the immediate cause of position failure. Everything else contributes, but the M2 delivers the final systematic destruction. November 1944. American forces begin using M2S in new configurations. Aircraft-mounted versions achieve higher rates of fire. Vehicle-mounted versions provide mobile suppressive fire during advances. The weapon's versatility allows tactical innovations that Japanese forces cannot counter. A bunker positioned to resist frontal assault finds itself engaged from 3 directions simultaneously by M2S mounted on advancing vehicles. The tactical flexibility of American forces, enabled by having M2 support everywhere, creates conditions where Japanese defensive doctrine becomes obsolete. Positions designed for static defense cannot adapt to fluid battlefield conditions. American forces bypass strong points, flank positions, isolate defenders, all while maintaining M2 suppression that prevents effective response. December 1944. As the war enters its fourth year, the cumulative effect of material advantage becomes absolute. American forces don't just have more M2s. They have more of everything: more aircraft, more ships, more artillery, more ammunition for every system. The M2 represents the baseline capability that enables everything else. Japanese defensive manuals now include sections on fighting without bunker protection. The acknowledgement is implicit: positions will be suppressed, bunkers will fall. Infantry must be prepared to defend in the open using terrain for cover. The doctrine recognizes reality. American firepower superiority makes traditional defensive strongpoints untenable. January 1945. 4 years after Pearl Harbor, Matsuda's analysis of the M2 Browning becomes part of a larger assessment of military-industrial capacity. The conclusions are classified at the highest level, shared only with senior leadership. The numbers tell an unambiguous story. Japan cannot sustain current loss rates beyond mid-year without complete collapse of organized resistance. The M2 Browning is mentioned in the assessment as one example among many. American production across all categories of equipment continues increasing. Japanese production continues declining. The trajectory is clear. The only question is how the war concludes, not whether Japan can change the outcome through improved equipment or tactics. February 1945. The Battle of Iwo Jima demonstrates the ultimate development of both American M2 tactics and Japanese defensive adaptations. Japanese positions are deeply buried, reinforced with everything available, positioned in volcanic rock that offers better protection than coconut logs. American forces still advance, supported by M2 fire that supplements artillery and naval bombardment. The island falls in 5 weeks. Japanese casualty rates on Iwo Jima are catastrophic. 95% of the garrison killed or captured. American casualties are high by Pacific Campaign standards, but represent a sustainable loss rate given reinforcement capabilities. The mathematics of attrition clearly favor the force with unlimited material resources and the industrial capacity to produce weapons like the M2 in unlimited quantities. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.